Here you see, it's just the feedback circuit for making the biasing. I place here the output current I want, I1, that is the IDS that I want. I make it proportional with the width, and there's some reference width that I start with and the current. So that is just the reference number. So this is now proportional, keeping the device exactly at critical inversion. This is how this reference width and current are evaluated. So then I increase the current, but if I increase the current, I need to apply a different VGS, and that is what the loop takes care of. That is just the biasing as we discussed it in the finding the equivalent input bias sources. I hope you remember from the biasing of the CS stage. But in this case, I put a large capacitor there because the loop must only be active for DC and not for frequency signals of interest. Otherwise, any variation on node 6 will be compensated in the loop, which is also noise. So in order to kill the performance of the loop for very high frequency, I just put 1 farad there. And you can check by using an AC analysis if this is good enough, or if you have to make the loop gain smaller or the capacitor larger or smaller or whatever you want. But this is good enough for millihertz, I guess. So then I put this 600 ohm there. And this is a noisy resistor, and we can calculate the noise contribution at the output, and we can calculate the contribution of the FET to the output noise, and in this way we can calculate the noise figure. This is what I will do in a demonstration in the next session. But the results very much, as you will see, will depend on library models used. I have 2 different CMOS 18 libraries included, and you see 1 dB difference in the value, and that is something you have to get used to. The devices you get and the simulations are as good as your model parameters. And I have seen situations in which the noise was not good enough modeled, and it needed to be redone. Extra measurement needed to be done to get better noise models, because it was very important for the design. So that's why it's always good to check if measured data of the noise can be generated from the models, because that is not always the case, and it's really good to check this if you are doing design.